Hi everyone, I am Sai Kiran. I am currently pursuing BTech in Electrical Engineering at Aditya College of Engineering and Technology in third year. Today we are going to explain Embedded System Internship provided by Emertxe. In this internship, we have formed a group of 3 members and other 2 members are Mr. Yashwant and Mr. Aprup. We are going to start our presentation. First, we are going to learn about embedded C programming basics. First one is microcontroller. So, microcontroller to control the microcontroller, we use embedded C language, which is effective and efficient language for the microcontroller. Second one is timer management. Using of timers in embedded C will help to accurate timing operations for a specific task or a synchronous task. Third one is peripheral management. Embedded C facilitates easy interaction with various types of peripherals like sensors, actuators in the system. Fourth one is switch debouncing. Implementing debouncing techniques in embedded C improves reliability in switch-based user input handling. Best practices for embedded C. Code comments. Comments will helpful to clarify the function, which helps to easier to debugging and updates. And in meaning, second one is meaningful names. In meaningful names, we use macros instead of variables, which helps for reliability and understanding. Third one is design, modular design. So we divide program into different functions, which helps to promote reusability. Error handling. It implements error checks and prevents system crashes during operations. And fifth one is efficient loops. By writing loops, it will optimize performance of system. And sixth one is power management. Next, data types in embedded C. So in there are more types of data types in embedded C. In few are mentioned here. First one is integer, which helps for counting operations, and second one is character, which helps for character input for control operation. Next data type is unsigned for non-negative values in calculations, and third one and fourth one is Boolean data types, which is true or false. In the embedded C helps for on or off operation states. And fifth one is array, which helps to store multiple values for efficient data management in loops. Next, control structures are control statements in embedded C. There are so many statements, few are mentioned. First one is if statement, which helps to take decisions. Whenever decision making condition is there, if statement is used. Otherwise, else statement. Default statement is the else statement. And third one is switch statement. Switch statement enables the selection between multiple washing programs. And fourth one is for loop, which helps to do the repeat operations. And fifth one is while loop, which helps to keep up checking user inputs until a specific condition is met. And sixth one is delay functions, which passes execution for a specific period of time. Advantages or benefits of embedded C. First one is control, direct hardware control for a optimized performance. Second one is efficiency. Third one is flexibility. And fourth one is modularity. And next, tools for embedded system developments. First, there are so many tools and few are mentioned. First one is MPLAB, which we write the code and debug the code. And XC8 compiler is the compiler which converts our embedded C code into hex file. And PICSimLab is a virtual testing of embedded systems. It's a simulation tool which helps to test the embedded systems without actual hardware. Here we use PIC16F877A microcontroller, and we use CLCD display, which helps to represent information or status of the operation. Next one is tactile switches, which provides user inputs, and timers, which manages operation timings effectively during program execution. And next one is MPLAB. About briefly of MPLAB, we have code editing, which we write code efficiently and edit, and debugging tools, which have advanced features and simulation support, and project management and compile integration seamlessly link with XC8 compiler and user interface. Initiative interface helps streamline development process. And next, XC8 compiler functionality, which has code completion, which converts our embedded C into the X file, and debugging support. It offers real-time debugging tools and integration. It will XC8 compare is simply integrates with the MPLAB and optimization and improves code efficiency and memory management, and it has library access which has essential libraries for easier peripheral interfacing. It's provide access. So PICSimLab, we have simulation tools which has PICSimLab, which has comprehensive element for simulating embedded systems and user interaction, which has hands-on offering and hands-on approach to understand embedded systems without actual hardware. And third one is debugging support, which has debugging features like facilitating testing, troubleshooting of embedded code, and make it easier for developers to identify and rectify the issues during development. In PIC16F877A microcontroller features have memory types which has the static RAM, EEPROM, etc. And it has 33 input-output pins, and it has timers which have multiple timers for operation timing, and it has universal synchronous asynchronous receiver transmitter which is USART, and it has LCD supports, and it has designed for low power for in embedded applications. Memory management in PIC controller, it has program memory which is stored, utilize flash memory for storing firmware code, and the data is stored in RAM which is temporary, and store persistent data in EEPROM. And memory management, it choose a particular or suitable data type for conserve memory effectively, and its memory mapping, understand memory organization for effective program execution. So from now onwards, my teammate Ashwant will continue the presentation.
Hello everyone, I am Ashwant. I am pursuing Bachelor's of Technology in Electrical and Electronics Engineering. Now I am continuing Functions and Modular Programming. It has 4 stages: code segmentation, reusable functions, clear declaration, effective debugging. Code segmentation break code into manageable sections for better readability and maintenance. Reusable functions create functions for repeated tasks, improving efficiency and reducing redundancy. Clear declaration. Declare functions prototypes at the beginning for easier understanding of functionalities. Effective debugging. Isolates issues by testing individual functions. CLCD interface management. Here there are connections, installation, command execution, data handling. Establish connections between microcontroller and CLCD for display transfer. In installation, set CLCD mode and configure pins to control display functionality. Then we execute the command, and data handling manage data outputs, dynamically update user interface messages. Implementing switch debouncing techniques. There are 6 techniques. They are timing delay, step verification, interrupt handling, software debounce, filter noise, code efficiency. Timing delay introduces a short delay to ignore rapid switch bouncing. State verification, check switch state multiple times before configuring changes. Interrupt handling, use interrupts to detect press events, minimizing false triggers. Software debounce, implement a state mission to track switch transmissions accurately. Code efficiency, optimize debounce code for real-time performance and responsiveness. Timers and their applications. Cycle time, delay operations, event scheduling, timing control, LED indicators. Determining program execution and washing machine operation timingly. Timing controller delay functions. There are 5 types. They are delay functions, accurate timing, sequential actions, timing loops, role-in simulation. Delay timing utilize delay for millisecond control in operations. Sequential actions implement delays between operations for smoothen user experiences. Time loops create loops with delays to manage repetitive tasks effectively. Role-in simulation, time functions manage washing machine program flows accurately. Bitwise operations for GPIO control. They are set bit, clear bit, toggle bit, read bit. Set bit to turn on the LED, clear bit is to turn off the LED, toggle bit is to toggle that LED, read bit to check if the switch at port is pressed or not. GPIO configurations and management. TR trace settings, port installations, reading inputs, controlling outputs, debouncing switches, interrupt handling. Trace settings configure trace registers for input output direction for ports. Port installation. Set install states of GPIO ports before application execution. Reading inputs use port registers to read the states of tactic switches efficiently. Controlling outputs manipulate port registers to control LEDs and buffer states. Interrupt handling configure interrupts for rapid response to GPIO state changes. Introduction to embedded systems. An embedded system is a computer system with software embedded in hardware designed for a specific task within a large device or system. These are used in home applications, automobiles, and industrial machines. Understanding embedded systems. In home applications, embedded system in home applications optimize functionality, enabling the automation of tasks such as laundry, cooking, and refrigeration. Those improves users' convenience and energy efficiency. Automotive control. Modern vehicles rely on embedded systems for engine management, safety features, and entertainment systems. Enhances performance, safety, and overall driving experience for users. Industrial automation. Embedded systems play a crucial role in industrial automations. Control variety of controller-based projects. Home application, industrial automation, healthcare devices, smart agriculture. Microcontrollers are used in various home applications to automate tasks and improve energy efficiency. Industrial automations, they enable real-time monitoring and control of missions. Healthcare devices, microcontrollers power medical devices, facilitating patient monitoring and improving diagnostic accuracy. Smart agriculture, they are employing agriculture equipment for monitoring soil conditions and optimizing water usage. Functions and module programming. There are 4 stages: code segmentation, reusable functions, clear declaration, effective debugging. In code segmentation, break down code into manageable sections for better readability and maintenance. Reusable functions create functions for repeated tasks, improving efficiency and reducing redundancy. Clear declaration declare functions prototypes for the beginning for easier understanding of functionalities. Effective debugging isolate issues by texting individual functions, streamlining and debugging process. Creating customer header files. File creation, function declarations in individual guards, code organization. These are the creating custom header files. In file creation, develop header files to encryption specific functionalities, and file declarations include function prototypes to facilitate a modular programming. Include guards include guards to prevent multiple instructions. Code organization organize related functions and definitions for better readability. Interrupt handling in embedded systems. There are 6 stages: event detection, time interrupters, ISR design, debouncing switches, low power mode, nested interrupts. In event detection, utilize interrupts to identify button presses for immediate actions. Timer interrupters use timer interrupt for periodic updates in washing machines simulations. Debugging switches implement debouncing logic in ISR to avoid erroneous multiple triggering. Low power mode use sleep modes and wake up interrupts to save power efficiency. Nested interrupts allow higher priority interrupts to preempt low priority one of responsiveness. Now my friend Apru will continue.
Thank you, Ashwan, for this wonderful opportunity. I am Aprup. I'm studying BTech third year in EEE stream. I'm going to explain about project architecture overview. There are 7 stages: user input, program selection, water level, start program, operation status, completion alert, remove close. In this, user gives an input with the tactical switches. Program selection is displayed. We have to choose the displayed options. Water level is desired to set the water level. Start program, pressing the start button initializes the selected cycle. Okay. Operation status, currently active washing stage is displayed on the screen. Completion alert, user is notified when the washing machine cycle is ends. Remove close, this is the final message after completion of the washing machine program. Next thing, in this we have components, input components and their functions. There are 8 input components like door switch, program selector, start button, water level control, pause button, menu navigation, status LEDs, and buzzer alert. This door switch, it detects if the door is closed for the safe operation. And start button, It initializes the washing cycle once pressed. Pause button pauses the current washing cycle after the button is pressed. Program selector, it allows the choose the between different washing programs. Water level control. Let's user select the desired water level for washing. Menu navigation enables user to navigate through different settings easily. Status LEDs, it indicates the current state of washing machine. Buzzer alert provides audible warnings and completion cycles or errors. Output components explained. Output components. There are 5 output components like CLCD, buzzer, LCD, switches, timers. CLCD displays the prompts and the warnings or operational status in the display. Buzzer, it gives the audible signals like if the error is occurred or completion of the program. LEDs. These LEDs indicates the washing progress and different operational states. Switches provides user inputs for starting, pausing, and washing programs. Timers. These are the crucial part. This controls the delay of delay of the process in washing cycle. Peripherals used in the user interaction. It is very important. User should be easy to operate and easy to control. So these are the peripherals which is helped very easily by user. CLCD, buzzer, LEDs, tactical switches, timers, power control, menu navigation. CLCD, it displays the messages. Okay, and buzzer, it indicates the completion or errors. LEDs, switches, they provide the status of the program. Tactical switches allows to user input operation. It allows to input by user. Timers manage timing for washing programs which are cycle dependent. Power control, save power on and off functionality for user safety. Menu navigation enables easily selection, washing programs and options. This is the feature flow implementation overview. And in this we have 5 stages: power on, program selection, water selection, start or pause, function execution. Power on is the major part. It is sourcing the washing machine. Program selection, we need to select the program, which type of clothes you are washing. Water level, it is desired by the clothes. It is dependent on the what type of clothes are you washing. Start or pause, press the start button to begin or pause the operations. Function execution, current washing status is displayed throughout the operation. This is the flow chart of power on screen. If you start while if the power is on, it will start. If the yes, it will continue and end. If no, it will go out of the loop and end. This is the power on screen interaction. Washing machine program selection process. This is the selection process. In this, we navigate the switches. What should we use? Mainly, we use only 3 switches: switch 5, switch 4, and switch 6. For power on, you should use switch 5. For navigating, you use switch 4. For a selecting program, we use again switch 5. For navigation, again we use switch 4, water level. For confirm selection, we use switch 5. Start the program, we use switch 5. And the pause the operation, we use switch 6. After completing, buzzer will alert. Water level selection. In this, we use switch 4. Switch 4 to navigate. After that, we choose the levels like auto, low, medium, and high and max levels. Confirm the selection. Confirm selections used by long press of the switch 4. After that, we need to start the program by pressing the switch 5. This is the water level selection mechanism. This is the start or stop functionality of the machine. We use switch 5 to power on the washing machine. Selecting program, it is the desired thing. We should navigate and choose that. Set water level, choose any appropriate water level for washing. Start operation, switch 5 is used to initiate the washing machine process. Pause, for pausing, you want to use the switch 6. After that, to resume that, switch 5 is used again. These are the indicator displays during operation. CLCD, LEDs, buzzer, user inputs. CLCD displays the current washing stage and remaining effectively. LEDs, these are the indicates operational status of washing, rinsing, and spinning. Buzzer, it is audibly alert signals completion of the washing cycle. User inputs, switches allow user to start, pause, or choose settings. completion screen and alerts. These are the completion screen and alerts. Status display. It gives a message or prompts you should choose or a completion. Audible alerts. Buzzer will give the audible alerts if there is a problem or facing any problem or the completion of the process. User instructions prompts users to remove clothes after washing cycle finishes. Final status LED. LED indicates the operational status. Before I have said program reset option. This is the program reset option. Provides a prompt to restart the washing machine program. Buzzer control logic. This is the logic we have dumped in the code. Port control. Set the GPIO buzzer as output. Setting activate buzzer. Use code to turn on the buzzer with high signal. Use low signal to stop the buzzer operation. Delay implementation. We need to initialize the delay by milliseconds by passing the milliseconds. Sound combination. Create different sound patterns by varying on and off ratios. Test routine. Develop simple sequence test buzzer functionally. Error indication. If the error is on, the buzzer will on and it will give audible signal. Challenges encountered during development. There are many challenges we have faced during the code implementation. Mainly, there are 4: LCD glitches, switch bounds, timer mismatches, debugging difficulties. LCD glitches, addressing issues with the display refresh rates and synchronization. Switch bounds, implementing software demounts to filter erratic switch inputs. Resolving discrepancies in timing and accurate operational logic. Using MPLAB tools and troubleshoot fixing and simulation errors. Learning from simulation process. Improved debugging, code modularity, effective debouncing, peripheral management, simulation testing, time management. Utilizing debugging features to troubleshoot efficiently. Developing modular code is better reliability. Implement debounce techniques to ensure accurate switch inputs. Gained insights managing multiple peripherals simultaneously. Conducted virtual tests to validate functionality without hardware. Learned to effectively utilize timers for operational time. This is the completion of the project summary. Importance of embedded systems. We know the importance of embedded systems. It is used in many ways, many things in the modern life. PIC16 microcontroller is the heart of this whole project. Simulation tools we have used: MPLAB, PICSimLab, and XC8 compiler. User interaction design. Design is intuitive interface with clear user input and output mechanism. Operational flow explained. The simulation follows a structured approach from power on to power completion. Challenges addressed. Implementing solutions to issues. Okay, thank you. Now my friend Sai Kiran will explain the code and simulation.
Thank you, Apurv. So in this MPLAB, we are going to show the code that we written for washing machine, and these are the header files and .c files that we use, and this is the code main.c code, and this is the ccld code for source files, and this is the digital keypad code, and this is the timer code, and this is the PIC16 header file, and this is the LCD header file, and this is the IRC main file, and this is the washing machine file, and this is the user defined header files, and these are the macros for washing machine, and these are the keys for digital keys. These are the macros that we have created for digital keypad. For switch 1, switch 2, I mean for port B. For port D, we have created macros. Okay, in PICSimLab, we have to select the microcontroller. So we selected the PIC16877A microcontroller, and we have to load the executed file from the MPLAB, and so we have to we are loading the X file and from the path that given stored X file, and this is the hex file that executed from MPLAB. Not executed, it is debugged. So the program is successfully executed by the microcontroller. So here we see the operation, and these are the switches: RB0, which is the switch 1. So, and these are the switches: RB1, RB2, RB4, RB5. These are the switches. RB5 is the key 5 which we are going to start our washing machine, and this is the LCD screen where we have to see where where we are going to see the modes. And by selecting RB3 or switch 4, we are going to scroll down what are the modes available in the washing machine. So we have eco cottons, woolens. For bed sheets, we have different types of washing techniques and different timings: rinse plus dry, dry only, wash only, aqua store, and daily, heavy, delicates, whites, stain wash. And these are the different types of program modes that we mentioned. And if we want to select particular mode, we have to long press the switch. After that, we selecting that mode, and after that, we going to see the LED screen water level. We have to select how much how much water level you wanted: low, high, max, auto, medium. These are the different water levels. So you have to select one water level by pressing the switch long press. After that, it's going to select. So yeah, in LCD screen, you shown that switch 5 is used for start and switch 6 is used for stop. Switch 5 is nothing but an RB4 switch. When we press the switch, the washing machine are going to start its operation or wash the cloths. And here we can see the whether the washing machine is rotating or not by seeing the fan, which is a motor in hardware functions. And here we can see the timer. This is the timer. And another important thing is if we want to stop or pass the washing machine from washing, we use the 6 switch, which is nothing but an RB5. Or if we want to start the operation, we have to select the RB4 switch. So you can see it's the door open. When there is a warning, I mean when there is a door is open, the operation will be stopped automatically. And operation will be stopped. So we have to wait until the times get 0. After the time gets 0, we are seeing that remove, I mean you can see in LCD that remove the class will be shown on the LCD. As I said before, if you want to stop the washing machine, you have to select RB5. If you want to start the machine, you have to select RB4. So this is the working of a washing machine. Total overview of the washing machine program. And thank you for giving wonderful opportunity to explain it.